tonight. Just want to show you. This is the cell that I created with the reconstituted zinc oxide, silica gel, Epsom salt, doped with galena and iron pyrite. You can see the blue from the silica gel crystal litter that's been incorporated in there. In any event, this is dry. What I did was I reconstituted the material using water, and here is the previously dried mixture. Again, you can see the paste that I have here, so that's just basic water and the previously constituted and heated and molten salts. So I applied it to the magnesium and a piece of carbon, and I sandwiched it in this small little vise. I then utilized my power supply here, which I had set to 31 volts, 0.75 amps. And I repeatedly hit this, and I noted that the electrolyte was bubbling. And I kept on doing that until the voltage source read 31 volts, and it didn't seem as if anything else was going across this. But I just want to show you where the voltage is. And again, this I did around 1 p.m. this afternoon, and you'll see where it is right now. So here we have on that scale, okay, so I'm going to need to move it up once. It's a 20 volt scale. And I have not received I have not had any previous success like this to get it to this voltage level. So here you are. So it's at 2.61 volts, okay? That's just one cell. That's it. Now I'll show you as a comparison. Here's one of my previous dry cells, and this has just kept right on going. This has not been altered, not been redesiccated or rehydrated except one time, and that was at least almost a week ago. So if I hook this one up here, you will see a voltage of 1.51 volts. So in essence, with this, even a smaller surface area here, that carbon electrode's smaller in surface area than what I have on this one, yet I was achieving 2.6 volts out of that. And here is another little cell. This one I have written on there recon, and this again was the reconstituted salt mixture. You can see the oxide on that from the initial zapping of it. And again, I basically hit this with the same 31 volts, 0.75 amps, until it stopped bubbling. And again, you'll be able to see, what this is making here is definitely nothing to sneeze at. So let's see if I can put this up here. Okay, so I've got that there. Hold it right in front of it, and you can see 1.58 volts, and that's dry as a bone. That was from yesterday, so there's nothing going on there. It's about 20 milliamp hours. So again, that's encouraging news that we may be able to create this molten salts, and even if we're not able to apply them adequately to the metal, we may be able to reconstitute them and then electrically plate them to the constituent electrodes and get a decent cell. And again, I'm very, very much encouraged by this carbon cell, which is smaller than my original pile cell, and a 1 cell thickness. I'm getting, again, 2.6 volts. Again, I'll show that one more time here. So here is the negative, here is the positive. It's 2.61 volts, 2.62 volts. So, Nick Z, we can get better than 2 volts. How long it stays there remains to be seen, but again, I made this at 1 p.m. and it is now 9 p.m. Central Standard Time. And as a matter of fact, it seems like it's going up, because when I first checked it was 2.61 volts, and it seems like it wants to teeter on the way up. So if something else is happening with that oxide layer, and I just don't think it's just galvanic action that's delayed. So for what it's worth, have a great night. Thank you, folks.